of you have been asking about the multiple choice review that I put up. I did upload some videos, but a problem that I did not upload that has been coming up is problem number 9. And so I want to take a couple minutes and go over how we would approach number 9. So the first thing that number 9 says is the graph of the function f shown above consists of two line segments. If the function g is an antiderivative of f. So that's what I'm going to write down first. If I know that g is the antiderivative of f. Okay. And then it also tells me that g of 2 is equal to 5. That's an initial condition that's going to become important for us. For how many values of c between 0 and 6 does g of c equal 2? So if I want to figure out g of c, I want to know when g of c is going to equal 2. So the first thing that I'm going to do is figure out what g of c is. I am going to use this initial condition right here. Remember, we always start with the initial. The initial is g of 2 plus the antiderivative of f of x dx. Now we have to figure out what number is going to go right down there on the bottom. Whatever our initial condition is, wherever our initial condition starts, it starts at 2, that's going to go at the bottom of my integral. So basically this is where we're at 2, and this is going to be our change from 2 to c, which is any value. And I want to know when this right here is equal to 2. That's what our problem says. When does this equal 2? So let's try to solve this. Well, g of 2 is 5 plus the integral from 2 to c of f of x dx is equal to 2. I'm going to subtract 5 from both sides. And when I do that, I have the integral from 2 to c of f of x dx equals -3. So my goal for this problem is to figure out how many different values of c could I have that if I integrated from 2 to c, I would get a value of -3. Well, integration is just the area underneath the curve. So the first thing I'm going to do is find the area underneath these curves. This over here is a triangle. I know that the area of a triangle is 1/2 base times height. My height of this triangle is 4. Oops. My base of this triangle, it's kind of hard to see here. It's a little bit larger than 1. To figure out exactly where that's at, I could find the slope of this straight line. That did tell us that it was linear. So my slope is -3 over 1. So my slope, this is sloping down at a slope of 3. So this right here would be 1/3. Okay. And then if I moved over another third, I'd go down 1. And if I moved over another third, I'd go down 1. Okay, so if I simplified this right here, I am going to have, let me rephrase this. This base is 1 1/3. This little piece is 1/3. So let me rewrite that. 1 1/3 is 4/3. Sorry, I'm not going to restart the video. So if I were to simplify this right here, 1/2 of 4 is 2, and I end up with 8/3. So my area up top here is 8/3. I also want to find my area down here. Now, instead of just treating this like one big triangle, I'm going to cut it off at 2. And the reason that I'm going to cut it off at 2 is because at the bottom of this integral, things are starting at 2. And so I'm going to find this little area, which is 1/2 base times height. The height here is 2. The base here is 2/3. So the 1/2 and the 2 can cancel each other off, and this little area in here is simply 2/3. It is negative because it's underneath. Then I'm going to move to this triangle, which is 1/2 base times height. This one's a little bit more straightforward. The base is 2, the height is 2. This is going to be an area of 2. I'll call it -2 since it's underneath the x-axis. Then I'm going to move over to my last triangle over here, which again is 1/2. The base is 2, the height is 2. This one's going to be a +2. Okay, now I know what all those areas are. So now I need to figure out if I'm integrating from 2 to any value, will I be able to get -3? Well, let's start at 2. 2 is right here. if I integrate from 2 to any positive value, let's say that I integrated from 2 to 4. If I integrated from 2 to 4, my area is -2. That's not -3. And then if I went further from 2 maybe up to 6, I keep getting more positive in my answer. There's no way for this C value to be larger than 2 for this to work. Because if I integrate again from 2 to 4, I get -2. That's the smallest number I can get. If I integrate from 2 to anything bigger than 4, my area starts to get larger than -2. It's no way going to get to here. Now let's see what would happen if we worked backwards. Let's say that this C value was something that was smaller than 2. So if I integrated from 2 to 0, let's imagine that we're going to go from 2 to 0. If I go from 2 to 0, remember we like to switch that so that the smaller number's on the bottom and we simply just put a negative out front. Let's see what we would get in this case. If I integrated from 0 to 2, I have a negative out front, and my area up top is 8/3. My area on the bottom is -2/3. If I were to do this, I get 6/3, which is 2. Negative out front makes it -2. That's the smallest I can get. There's no way for me to have a C value and end up with an area of -3. Therefore, my answer is going to be 0. I hope that helped, and I hope to see some of you on the watching the AP Classroom or AP College Board live sessions later.